Hi students, welcome back. Today we are going to look at three-sum problem on LeetCode. We have already looked at two-sum problem. This is like a next step to that. Let's look at the problem statement problem statement. The problem statement says we are given an integer array nums and we have to return all the triplets such that sum is equal to 0. So the sum of the three numbers in this case should be 0. We have to find out all such triplets and we have to return them. And it also says that the solution set must not contain any duplicates. So if there are any duplicates, we'll have to remove them as well. So in the two-sum problem, we were guaranteed that there was exactly one solution. Here, that's not the case. There can be one or more, zero or more solutions for that matter. And we should not return any duplicates. Okay, let's look at an example first. Here, let's say this is the given input array. So we have to find three numbers such that the sum is 0. So one such set is -1, -1, 2. The other such set is -1, 0, 1. Clearly, sum of them is 0. Okay. And these are distinct triplets. We should not repeat any of them again. Now let's look at another example. So in this case, for the given input, there is no three-sum possible. That is why we return an empty array. Now let's look at another example. Here, all the inputs are 0. So there is one possibility where all the three numbers are 0. We have to return such that result. So here if you notice, the numbers can repeat, but we have to use them exactly the number of times they occur. Okay, let's say here if the input is just 1, 0, okay, we can't return the output as 0, 0, 0. Okay, this won't be correct because 0 occurs only once. Here 0 occurs 3 times, which is why this is a valid input. Okay, so let's look at it through an example. Okay, so in case of two sum, if you remember, we used a hash map approach. In this case, that won't really work for us because hash map worked because we were guaranteed exactly one solution there. Here, there can be 0 or more solutions, which is why that hash map approach may not work. Okay, so what is the problem statement? The problem statement says, okay, we have to find three numbers x, y, z such that it is equal to 0. Okay, similar to two sum, what we will do is we will fix the current value. Let's say the current value is 6. We have to find two numbers such that their sum is equal to -x. Okay, so we will reduce the three sum problem to two sum problem using this. So let's say we take this example, which is -1, 0, 1, 2, -1, 4. Okay, -1, 0, 1, 2, -1, 4. What we will do is, let's say we fix -1. In the rest of the array, we will find two numbers such that their sum is equal to 1. Okay, this is the approach we will do to reduce the three sum to two sum. Now, how do we find two sum when multiple solutions are possible, the numbers repeat and all that? Like we discussed, the hash map approach will not work. So the other solution which we can try is we can look at a sorting approach for this. So let's take a sample, an example for this. Let's say the input is 0, 1, 2, 3, 5, 6, 9, and 10. Okay, I intentionally took it sorted. If it is not sorted, our first step is to sort it. So this algorithm requires a sorted number. So what we will do is, so our goal here is find two numbers such that their sum is equal to a certain number. Let's say in this example, let's say our sum is 9. Okay, what this value is doesn't really matter. Okay, algorithm will still work. So we have to find x and y such that their sum is 9 and we have to find all possible combinations of that. Okay. So what we will do is we will take two pointers left and right. So left starts here and right starts here. So at each step what we will do is we'll do x plus y. So here left plus right basically. Here left plus right is 10. Okay. And we are looking for two numbers which equal 9. So 10 is greater than the required value. So that means the two pointers we took, they are greater than the required value. So what should we do to reduce the value? So our result is less than that. So to reduce it, right side we have bigger numbers. So we have to move the right pointer. So if the value is greater, what we will do is we will do right minus minus. So we will move the right pointer here. Now left plus right is 0 plus 9, which is equal to 9. Okay. So in this case, we found a match. So we will add it to the result set. Okay. And now we have to find if there are more possible such things in the inner set. So for that, what we will do is we will do both left plus plus and right minus minus. Okay. So when we do that, our left pointer will come here and right pointer will come here. Now in this case, our sum is 1 plus 6, which is 7. Okay. And we are looking for 9. So this 7 is less than 9. So whatever is required is less. So we need bigger number. How will we get a bigger number? If we advance the left pointer. Because it is sorted. If you advance the left pointer, you will get a bigger value. So if it is less, you will have to do left plus plus. Okay. Now the left is at 2, right is at 6. 6 plus 2, 8. It is still less, which is this case. So we will do a left plus plus again. 6 plus 3, 9. 9 is equal. So we will add it to the result set and we will do left plus plus and right minus minus. So left will come here, right will come here. So what is our break condition? We will do this as long as left is less than right. Okay, once this condition is not true, we won't do it because we have seen all the numbers. So now we will break. So we will start with two pointers left and right. If the sum is greater, that means we are having a bigger number than the required. So we will reduce right. If the sum is equal, that means we got the match. So we will add it to the result set and we will look at the subset of it. If the sum is less, that means we have to increase the number. Since it's sorted, we will increment the left pointer for it. So these are the three conditions to find the what is it called? Sum, two numbers which equal to a sum in a sorted array. Sorted is the important thing. Otherwise, left plus plus, right minus minus doesn't mean anything. If it is not sorted, even if you do right minus minus, there is no guarantee that you'll get a lesser number, right? Which is why sorting is important in this case. So what we will do is, what is our algorithm is, we will sort the given input and for each number, we will fix the current number and in the rest of the array, we will apply this to some algorithm. Okay. Let's try to write the code for it. Okay. So first step is our algorithm needs a sorted input. So let's sort the array. Okay. Now we have a sorted array. Now, so to capture the result, we will need a array list. So our result is a list of integers. Okay. So let's create a result array. Now we have to, for each element in this array, we have to fix the current element and we have to apply the to sum on rest of the elements. So let's take the current element as n. Okay. And let's apply to sum on this. So to apply to sum, first left would be I plus 1 and right would be length minus 1. So let's create left and right pointers and we will do while left less than right. So whatever we have discussed earlier. Okay. And we will find the sum first. Okay. Here n is the current integer. Okay. So here, if sum is greater than 0, what we have to do is we have to do write minus minus, because we have a bigger number than what we need, which is why we will do write minus minus so that we get a smaller number. If sum is less than 0, that means we have a smaller number, which is why we will do left plus plus. Else, what we will do is we will add the current value to the result. Okay. So in this case, the sum is equal, which is why what we will do is we will add the current xy values to the result, xy and also n. Okay. Okay, so result dot add, we are creating a new array list with n nums of left, nums of right, and adding it to the result. And we will increment left, decrement right. Okay, at the end, what we should do is we should return the result. Okay, let's see, let's run this and see. So here we didn't get the correct answer in this case. If you see, the output we gave is -1, -1, 2, -1, 0, 1, -1, 0, 1. While the expected solution should not contain duplicates. So that is the thing we missed. So how can we fix it? So since it is sorted array, duplicates always occur next to each other. What we can do is when we find a result, we can advance the pointers as long as there are duplicates. So for example, if nums of right is equal to nums of right minus 1, we can keep doing right minus minus because they are sorted. The duplicates will lie next to each other. The similar thing we can do for a left pointer as well. If nums of left is equal to left plus 1 in this case, because left is moving forward, right is moving backward, we can do left plus plus. Okay, this itself is not enough. We have to do one more condition where we should not even enter this if the current value, which is nums of I, is equal to I minus 1. Okay, that is because there can be a case where there are only two duplicates, you processed one, you shouldn't even enter here if the next one is also same as the previous one. Okay, so that is that this will be caught by that case. Okay, let's see, let's run this and see. So now we have successfully removed the duplicates. So here we are advancing the pointers until we find the next distinct element. Here what we are doing is we are not going to process if the current number is same as the previous number. Okay, simple. And since we are looking for sum equal to 0, there is one more optimization we can do. So if the current value is greater than 0, okay, that means we have reached the positive side of the array. There is no way we will find three numbers such that sum is 0. So we can just break in that case. Okay. This is one more optimization that we can do. So let's submit this and see. Okay. So this has it beats 99% of the users. So the solution has worked. Here if you see what is the time complexity. Here for sorting, yeah. Okay, for sorting it is n log n. Okay, and for here we are processing the array twice, which is n square. Okay, so the time complexity is order of n log n plus order of n square. And what is the space complexity? Space complexity is, are we using any extra memory? Nothing as such. This result is just to return the result. So we don't need any extra space. Okay. So that's all for today. Hope you enjoyed this problem. This is like a next step for the two sum problem. So do go through the two sum video first before you attempt this one. Okay. Thanks for watching. Please like, share and subscribe. Thank you.